All right, so these are the notes for the continuation of the notes for the conic parabola. All right, so first thing I just wanted to I'm going to keep mentioning back to these two equations. These are the general forms of the conic parabola. So x minus h squared equals 4p y minus k. Y minus k squared equals 4p x minus h. Okay, so the first thing we're going to talk about is the vertex. So when you're writing the vertex, it's going to be h comma k. So for this one, it's the opposite. Opposite of this is h, opposite of this is k. One thing I want to point out is when you look at the y squared one, notice that k and h are flipped because h is always with x and k is always with y. So when y squared comes first, but remember it should be hk still. So regardless, it's going to be hk. Just remember this one, it's what we're used to seeing. This one here, it's backwards. So the h comes first and then the k second. All right, for the opening, there's going to be two types of openings. So your first opening is going to be when x is squared. So when x is squared, we have two possibilities, okay? So we're looking at this one when this x term is squared. We're going to look at this 4p value. If 4p is greater than 0, which means that it's positive, then our graph is going to open up. And I'm drawing in the focus, the vertex, and the directions of that. So this one opens up. Now, if your 4p value is less than 0, which means it's negative, then your graph is going to open down. Okay. Now, on the other hand, now you're going to have y squared. And this is when y is squared first. The first term squared is y. So now we're going to still look back at 4p, and notice 4p is still in the same spot for both of them. Is that 4p is greater than 0, which once again means it's positive. Now you write it again. Your graph is going to open to the right. If your 4p value is less than 0, which means it is negative, then your graph is going to open to the left. So those are going to be your four possible openings for x squared and y squared. Now next we have the focus. And for the focus, you're going to do it actually with the directrix. You're going to solve for p, which is right here, for p. And pretty much there's going to actually be a value. Like let's say this, instead of this 4p, there was the number 8 there. We're going to say 4p equals 8, and we're going to solve for p by dividing by 4. Okay. Now, for the focus, I just want to talk about it. This is going to be a point, right? You learned in the attributes that a focus is a point. So we're going to write that as x comma y. So it's a point. You write that y a little bit better because that kind of looks strange. So it's a point, x comma y. For the directrix, hopefully you know that is going to be a line, and it's going to be an equation. So if the line is a vertical line, then we're going to have x equals some number. So x equals some constant. If our line is horizontal, then y is going to equal some constant. Okay, so in case you've forgotten that. And once again, you're going to solve these together when you solve 4p, 4p. And I'm going to show you how to do that in a bit. Now, next for the axis of symmetry. Okay, the axis of symmetry is going to be the same thing. It's going to be if it's a vertical line, x equals a constant. And if it's a horizontal line, y equals a constant. And this line will pass through the vertex and focal point. And I'll just call it the focus here. Okay, so this line, this axis of symmetry, will pass through the vertex and the focus. Now for the number of units on each side, pretty much what you're going to do is you're going to take the absolute value of 4p, so that 4p value you're going to make it positive. And then you're going to divide it by 2, which is going to give you the absolute value of 2p. And the last thing you're going to do is you're going to graph it. And when you graph it, just make sure you label everything. That's pretty much it. Okay, so these are the rules that you're going to follow to make these graphs and to solve them. All right, let's start with the first one here. Here's my first example. Now, the first thing it says is to find the vertex, okay? So first I always look to see where x is. So this is going to be h right here. Now you notice there's no number added or subtracted in parentheses, so we can assume that the h value is 0. Now the k value is with y. We do the opposite, so y plus 2, the opposite of positive 2 would be minus 2. So my vertex is at 0, negative 2. And I plot that point right there. Now for my opening, what I'm going to check is I'm going to look which term is squared. Is it x or y? So in this case I see it's x squared. So if x is squared, then my two possibilities are going to be up or down. And once again, we're looking at 4p. If that 4p value is positive, it opens up. If 4p is negative, it opens down. And once again, that's where 4p is located, okay? So right here, 4p is right there. So in this case, our 4p is a positive 8, which means my graph opens up. Now, I'm also going to draw a little sketch here, and I'll show you why in a moment why I'm drawing this sketch. Okay, so now, for the focus and the directrix, I did tell you we're going to solve 4p, 4p. Okay, so we're going to take 4p, and we're going to set it equal to what the value of 4p is. In this case, it is 8. So to solve for the letter p, we divide both sides by 4, and we get that p is equal to 2. All right, and hopefully you know that p is the distance from the vertex to the focus, and it's also the distance from the vertex to the directrix. Okay, so I labeled that as a V for the vertex. Now, the reason I drew this little graph is because I know that the focus is located right above the vertex. And how many units? 2 units. So if I go to the graph and I count up 1, 2 units, I plot a point, and that is my focus point. So the coordinates of that is the origin at 0, 0. Now the directrix, if you take a look, this is the vertex, it is below it. It's going to be 2 units below, so count 2 units below and draw your line. The length of the line does not matter. And I'm going to put a D on there for directrix. So the equation of this line, it's a horizontal line. If you've forgotten, you can come back up here. The horizontal line is y equals the constant. So in this case, y equals negative 1, negative 2, negative 3, negative 4. Y equals negative 4. For the axis of symmetry, I went and told you that this line will pass through the vertex and the focus. Okay, so I'm going to draw a dashed line passing through here, passing through the vertex and the focus, and the equation of that line, since it's a vertical line, is x equals the constant. In this case, x equals 0. And last, to finish up my graph, I need to know the number of units on each side of the focus. So in this case, we take the absolute value of 4p. In this case, 4p is 8. So the absolute value of 8, and we're going to divide it by 2. So the absolute value of 8 is 8. 8 divided by 2 is 4. Now it says number of units on each side of the focus. So I go to the focus, I count, since it's facing up, 4 units to the right, 1, 2, 3, 4, and 4 units to the left, 1, 2, 3, 4. Make my graph starting from the vertex. And there's my parabolic function. All right, and there's all my information that I gathered just from that. All right, I do have one more example. So let's go ahead and take a look at it real quick. So once again, the vertex, locate x. In this case, x is second, right? X minus 1. So the opposite of that is going to be positive 1. And for y, this is where k is. The opposite of positive 2 is negative 2. So there's my vertex. So go over here, 1, negative 2. And I can label that with the V for vertex. Now opening, we're going to go to look. There's the squared term. Y is squared. So my two possibilities are going to be left and right. Look at 4p. 4p is negative. Since it is negative, it's going to open to the left. And once again, I'm going to draw a rough little sketch of a parabola opening to the left. That way, so I know where my directrix, my focus, is in comparison to my vertex. For the focus of the directrix, we're going to solve 4p, 4p. Okay, so we're going to divide both sides by 4. And we get that p is equal to negative 3. Now, the negative just really tells you that the graph is opening in the negative direction. So in this case, we know it's going to the left. So I don't really worry about this negative sign. I just focus on the number 3, because the 3 is the distance from the vertex to the focus and the vertex to the directrix. So right here, my vertex is right here. The focus is to the left, 3 units. So 1, 2, 3. Let's put an F for focus. And then directrix is to the right, 3 units. 1, 2, 3. And I'm going to draw this line. Remember, doesn't matter how long you make it. I make mine pretty short. All right, so let's go. The coordinates of the focus, -1, -2, -1, -2. So -2, -2. For the directrix, 1, 2, 3, 4. It's a vertical line, so x is equal to 4. For my axis of symmetry, I told you it's the line that passes through the focus and the vertex. So in this case, it's a horizontal line, so y equals, and the constant is -2. The number of units on each side of the focus, we take the absolute value of 4p, which in this case is -12, and we divide it by 2. So the absolute value of -12 is 12. And we will divide that by 2, which is 6. So we go to the focus, and since it's open to the left, we count 6 units up. 1, 2, 3, 4, 5, 6, and 6 units down. 1, 2, 3, 4, 5, 6. Make my parabolic function. And there you go. You can also label this the axis of symmetry. I forgot in the previous problem. Sorry. All right, and that concludes the notes.